So in this video, we're going to explore the third and fourth intermolecular forces in this chapter. This third intermolecular force that's called hydrogen bonding, it's very similar to dipole-dipole because it is based off of a dipole or a polarity in a molecule. But it is so strong compared to just a regular dipole-dipole force that it gets its own category called hydrogen bonding. So in hydrogen bonding occurs in molecules that obviously have a hydrogen, but that hydrogen needs to be directly connected to either a oxygen, fluorine, or a nitrogen. Those are the only kinds of molecules that exhibit hydrogen bonding. And hydrogen bonding intermolecular force is due to a polar molecule or a dipole within the molecule. But because that dipole is so strong, it gets its own category called hydrogen bonding. So you can see that, dipole is about 2 kilojoules per mole. Hydrogen bonding is about 10 kilojoules per mole. So in hydrogen bonding, you have the dipole of one molecule line up with the dipole of another molecule. And again, for hydrogen bonding to occur, the molecule that is involved has to have a hydrogen that's directly connected to either an oxygen, a fluorine, or a nitrogen. So in HF, that molecule exhibits hydrogen bonding because the fluorine from one can have an intermolecular attraction to the hydrogen from another molecule. Water has lots of hydrogen bonding that occurs. And the reason why water can have lots of hydrogen bonding is because water can hydrogen bond with hydrogens from 2 separate water molecules. So this is actually the reason why water has such a high specific heat capacity and why that water bath that you guys often made in intro chem lab that you needed to boil, that's why it took so long to boil. And that's because it has a high specific heat, and it has a high specific heat because it has all of this hydrogen bonding, all of this intermolecular force that needs to be disrupted to get that water to the gaseous phase. So hydrogen bonding happens in water, happens a lot in biomolecules as well. If you go on in chemistry or biology, you'll learn about the structure of DNA. DNA is a molecule that has 2 separate strands, and those strands or portions of the molecule of the DNA are actually held together by hydrogen bonding that happens in certain areas of the molecule. So hydrogen bonding, it's my favorite intermolecular force. It is a super dipole-dipole force. You identify hydrogen bonding if you have a molecule that has hydrogen directly connected to an oxygen, fluorine, or a nitrogen. Our fourth and final intermolecular force is one that is seen in mixtures of ionic and polar molecules, and it's called IonDipole. So in an ion-dipole situation, you have an ionic compound like NaCl that is soluble, and we talked about ionic compounds. When they dissolve in aqueous solution, they break apart into their cations and anions. Those cations and anions are not just swimming around in solution without anything attracted to them. Those ions can be attracted to the dipole of a particular water molecule. So in a mixture of sodium chloride, which is what's kind of shown here, in a mixture of sodium chloride or salt water, you have not only hydrogen bonding occurring within each water molecule, but you have ion-dipole forces occurring between the polarity or the positive charge end of one water molecule and the negatively charged chlorine ion. You also have it occurring between the negatively charged oxygen in one water molecule and the positively charged ion in the other. So Ion dipole, it is the strongest intermolecular force we will talk about. And basically, ion dipole is an intermolecular force that will occur if you have a mixture of ionic, things with a metal and a nonmetal, mixtures of ionic and polar molecules. So in the next two videos, we're going to talk about how to use these 4 intermolecular forces and identify which ones are present in a particular molecule.